In this video, we're going to continue basic hypothesis testing, and this is part 2. It will be extraordinarily helpful if you watch part 1 first, because there are some prerequisite ideas which you need to know before you can really watch this video. One idea is that you need to know that alpha, and this is a Greek letter alpha. Some of my students, when I write this on the board, think it's a 2. This is a Greek letter alpha. And alpha is the probability of committing a type 1 error and if you recall from the last video, a type 1 error is the event of rejecting the null hypothesis when the null hypothesis is true. So you should know what a null hypothesis is, and that's symbolized by H with the subscript 0. That's the null hypothesis. And you should know what an alternative hypothesis is. That's an H with the subscript 1. And it turns out that alpha is so important in the field of statistics that it's given a term, and that term is called the significance level. The significance level. So, and it might be called the significance level of the statistical test if you want to really use all your words, the significance level of the statistical test. So basically, when we do any of the hypothesis tests that you're going to encounter in an introductory college statistics class, what we're going to do is we're going to have some kind of a study. And studies have different designs. You'll learn about that. And from this study, we will sample from a population. And there may be more than one sample. And in general, we can call these samples data. And we're basically going to do the mathematical analog of a trial. Essentially, we're going to be looking at 2 different mathematical models to see which model better fits the data. We have the null hypothesis, which is a mathematical model. For example, the null hypothesis could say there's no link between vaping and asthma. And then the alternative hypothesis would say there is a link between vaping and asthma. And then we do a study where we look at individuals with asthma and individuals without, and then we look at their habits in terms of vaping, and we see if there's a difference, and then we test to see if this difference is statistically significant. And when we compare these 2 hypotheses, I'm going to write this down. When we compare H0 and H1, these 2 hypotheses, the null and alternative hypothesis, one of the ways we can do this, and the computer will spit this out, almost every test that you're going to learn in a college stats class, you can do on a computer with very little hassle, and the computer will spit out a statistic called the p-value. And it's really just p. Nobody writes p-value. They just write p, and in a paper, in a scholarly article, it might say something like p is equal to 0.32, or it could say p is less than 0.05. It might say p is greater than 0.05. And if you remember my last video, you also should remember that 0.05 is 5%. And this is the standard alpha value that science has been willing to accept for pretty much since R.A. Fisher said 1 out of 20 seems like a good number. Scientists, psychologists, sociologists, market researchers, pretty much everybody has accepted this 5% as the standard type 1 error rate that we're willing to handle in a statistical test. So let's say we do a study. Let's say we did that hypothetical vaping study where the null hypothesis was that there was no link between vaping, and the alternative hypothesis was that there is a link between asthma and vaping. And we did this and we put it into the computer and we got a p-value. How do we interpret that p-value? Well, the rule is really simple. I'm going to write this down for you. If, and I'm going to call this the decision rule. If the p-value is less than or equal to the significance level, which is also called alpha, then we reject, and I'm just going to write REJ for reject, the null hypothesis. That's it. That's the rule. That's how you interpret a p-value. It's that simple. The computer does all the work, spits out this p-value, and all you have to do is see if the p-value is less than or equal to the significance level. Now, I told you 5% is the standard significance level. So I'm going to write 5% equals alpha because it's the standard level. So let's do a little example here. Let's say our vaping doesn't look right. Maybe there are 2 P's. Well, I don't know how to spell vaping, but let's say it's V-A-P-I-N-G. Let's say our vaping asthma study to see if there is a link between vaping and asthma that we do on the computer spits out a p-value, and I'm just making this up, of 0.03416. And really the computer will probably put a few more digits on there, probably 8 digits is what's going to come out of a computer. And if you look at this, this is approximately equal to 3.4%. Now, how did I know that? Well, if you want to convert a decimal to a percent, all you do is multiply by 100, which is equivalent to taking the decimal point and moving it 2 places to the right. Okay, so we have a p-value of about 3.4%. So let me write that here. So 3.4%. Okay. And the standard level of significance in most scientific endeavors is 5%. So I'm going to put this here. So here's your p-value, 3.4%. Here's your significance level, 5%. And you can see that 3.4% is certainly less than or equal to 5%. Therefore, the decision, and really this is what might be better called the appropriate decision, the appropriate decision is to reject the null hypothesis. Now, if you remember from my first video, when you have a basic two-sample design like an experimental group and a control group, or cases and controls, or is there a link between this and that, the null hypothesis is always that there's no link between this and that, and the alternative hypothesis is always that there is a link between this and that. So this tells us that there is a statistically significant link between vaping and asthma. So when you reject the null hypothesis, that's the same thing. Rejecting the null hypothesis is the same thing as saying statistically significant. I should write that down for you. I want to write it in a different color. So rejecting the null hypothesis is the same as saying that the results are statistically significant. That's what statistically significant means, rejecting the null hypothesis. Now, if we failed to reject the null hypothesis, that would be the same thing as saying the results are non-significant. Let me give you an example of failing to reject the null hypothesis. So let's look at our another hypothetical study. Let's look at let's say that the research question is there a link between let's say listening to loud music and asthma. So that could be a research question. Your null hypothesis is always that there's no link. And the alternative hypothesis would always be that there is a link. There is a link. And let me remind you that these two little vertical, tiny little line segments here, they're called ditto marks. I was just too lazy to write these over again, so they're called ditto marks. And let's say, again, we collect data. From a study, and we pipe it into a computer. The computer does the statistical test and spits out a p-value, let's say of 6.24%. Now I'm giving it to you as a percent. Different software, some software packages might print it as a percent, others might print it out as a decimal. Other computer packages may give you the choice. I love percentages, but it's better to do the math with decimals. If you're actually going to do the math by hand, always convert it to a decimal. That's my little tip for you today. But let's write the appropriate decision rules. So remember, the way we make our appropriate decision, I'm just going to write APPDEC. The way we make our appropriate decision is we have the rule: if the p-value is less than or equal to the significance level, then reject the null hypothesis. So let's put this in. So we have a p-value of 6.24%. And now I didn't give you a significance level in the real world. The significance level, the default significance level is almost always 5%. But in some questions, you might actually ask, a student might be asked to do it at a different significance level, and that could happen. I do that to my students. Plenty of professors do that to their students, to get the student used to the fact that really the 5% is completely arbitrary, but it's stuck. So let's look at this. So here we want to see if 6.24% is less than or equal to 5%. Now clearly it isn't. So we can't reject the null. And the only other possibility is to fail to reject the null. So here our appropriate decision is to fail to reject the null hypothesis. And another way of saying that is that the results are non-significant. Results are non-significant. Non-significant. So that's what it means to fail to reject the null hypothesis. So if we were to write this out in English, we would say there is no significant link between loud music and asthma. So what I've done here is I've given you two different p-values. I gave you a p-value that was less than 5%. That's that 3.4% over here. And I gave you a p-value that was greater than 5%. But I didn't give you a p-value that was exactly equal to 5%. But if you look at this here, it says in the rule, in the appropriate decision rule, it says if the p-value is less than or equal to the significance level, then reject the null hypothesis. So even if the p-value hits the significance level on the nose, you still reject the null hypothesis. And when you're given a p-value, unless your professor specifically tells you to round it off to the nearest whatever, if you're given a p-value, don't round it off. Just compare it to the significance level mathematically like this, unless your professor tells you to round it off first. And most professors won't, but I can't say there's, never a professor who might not say, here's a p-value from the computer, round it off to the nearest whatever. I wouldn't do that. I don't think many professors would do that, but in theory, I guess they probably could. So, in summary, we learned that it doesn't really matter what type of statistical test you're given in Statistics 1, in a college-level stats class. There are some tests where p-value might not be your first choice of a statistic, but in an introductory college stats class, you'll always be able to get a p-value. It might be an approximate p-value if they don't allow you to use the computer, but you'll still be able to get a pretty good idea of what the p-value is, and very often they'll give you the p-value. When you read a scholarly article in a journal, most statistical analyses present the p-value. They just hand it to you on a metaphorical silver platter, and they'll say, the results suggest a link between this and that, and then in parentheses it says P equals this. And you get the p-value right there. So this is a good little chunk for one video. So if you like this video, give me a thumbs up, subscribe to my channel so that when the new videos come, you'll get that little bell thing. If there's something that you don't understand or something I could have done better, shoot me a little respectful comment and I'll try to make the videos a little better. All right, thank you all for watching.